Alright guys, welcome to the third video in my introductory robotics series. In today's video we're going to be going over the electrical schematic of the robot arm that I showed you in the previous video. Specifically, we're going to be taking a look at push buttons and we're going to try to understand how they work. So what I have in my hand right here is the push button that I'm using in the robot. So you can see here, if I can get it to focus, when I click on it, you can hear like a little tactile feedback. And basically, I have a diagram below here to show you how the button actually works. Below, right here, these two are the actual electronic like symbols. So if you ever see it in a circuit, this is how they'll represent a push button. What I have up here is just a little bit like a more simpler version of that, so you can actually understand how it's being used in the circuit. When the button is off or when you're not pressing it, you have, well, first you can see that in this diagram, the button has 4 leads, 1, 2, 3, 4. And the leads that are going vertically are connected, but horizontally they're not connected when you haven't pressed it. And when you do, and you can see that the circuit is not complete because these two electrical pads on the inside of the button are not connected. But when you do press on the button and it becomes on, it gets turned on, these two pads get connected on the inside of the button. And now once that happens, this circuit gets completed, and now we have 5 volts running through. And we can read the value of this button by measuring, by like putting a pin on this side of the button, because as I said before, the button is connected vertically and it's only connected horizontally when you press on it. So if we're always checking the state of the button from this or this pin, then we know that when it's pressed, this circuit is complete. And when it's not pressed, the circuit is not complete. So we can use that change in value of the button voltage. We can use the Arduino to read that value and determine if the button is pressed or not. So let's go take a look at the actual Arduino circuit. And here is the total circuit with the push button and the Arduino. If it looks a little bit confusing, don't worry, we'll break it down. So first we have the Arduino in the center right here. We have the ground pin and the 5 volts pin. And we also have a digital pin number 4. And if you're wondering what a digital pin is, you could do a quick Google search, but I can give you a brief explanation. Pretty much the digital pin can read input as either high or low. So it either has an on state or an off state. Contrarily, there's also analog pins which can read variable values from like 0 to 123, for example, to 1023, for example. In our case, the button is either going to be on or off. There's no in-between state, which is why a digital pin will work. So now if we look at the circuit, we can see that 5 volts is traveling all the way to one side of the push button. The other side of the push button is both connected to digital pin 4 as well as to ground through a resistor. Now, if you're wondering what the point of the resistor is basically when the push button is closed, the circuit gets complete and 5 volts and ground get connected. However, in order to prevent a short circuit and limit the current flow, we add a resistor so that the value can still be read without shorting out our entire circuit. Now, when the push button is closed, as I mentioned before, we will have some circuit complete. So the Arduino can then read that state value and change it to either high or low in the program. And depending on the input, we can change that to however we feel and activate a motor, for instance. And here's the circuit for the button, all wired up, and the Arduino is powered. So you'll notice that when I press the button, the LED pin 13, which is right there, it'll turn on. So there you go. Cool. So yeah, it's the exact same diagram. It's the exact same circuit that was shown in the diagram. We have, if you look there, we have 5 volts and ground going to the breadboard. So this rail is now completely 5 volts, as you can see the red line. And then ground is all along the blue line. If you don't know how breadboards work, the side rails are all connected horizontally, while the rails in the middle are connected vertically. So we have 5 volts and ground going to the side power rails, and from there we're taking 5 volts and putting it into one end of the button. The other end of the button is directly connected through a 10,000 ohm resistor to ground, and the end of the side of the push button that has the resistor connected through ground is also connected to digital pin 2. And when I press the button, as I said before, the circuit gets complete. Arduino can read that and it'll turn on its internal LED. So now let's take a look at the code that I used to do this. Okay, so the code that I was using in the clip that you saw before is just the standard button code available. If you go to File in the Arduino IDE, if you go to File, Examples, Digital Button, this is what you'll end up getting. I'm not here to like show any code that I wrote because it's really simple code. So I'm just going to explain what all this means if you're new to programming. It'll help if you have some C or C++ background, but I can help explain all the Arduino specific stuff. So first we create two constants, as they say in the comments. The one is for the button and one is for the LED, which is the built-in LED on the Arduino. Then we also have another button. We have another variable that represents the button state. We set the LED pin as an output, and we also set the button pin as an output, as an input, sorry. And this is pretty self-explanatory because the LED is what's changing based on the input that you receive from the button. And to do this, we use the pin mode command, or the pin mode function, which is an Arduino specific function. It takes a pin number as the first parameter and the uh, type of input or output that that pin number is. So you can have input, output, and I believe the other option is input pull-up, which you'll learn what that means later on. And this is all in the setup function, which is run once before the main loop. So this is where you do all your initialization of variables and like initialization code for different motors, etc. In the future, you'll see what else we put in the setup. Then we have the loop, and the first thing you do in the loop is you read the state of the button using this function called digital read. And what that does is it does exactly what it sounds like. It reads the digital value of the pin at button pin. So digital read, as I mentioned before, the digital pins are used for either on or off states. So you can either, so digital read will return either a high or a low. And if the state of the button is high, then we want to turn the LED on, and if it's not high, then we want to turn it off. And this is a simple if-else statement, and we control the value of the LED, or we control like if the LED is on or not using digital write. And what digital write does is it sends either a high or low pulse to the specified pin. So digital write and then LED pin and then high or low. And this is really basic code, but this is a good foundation for what we're going to be learning next. The same way that we're interpreting the button to be turned on or off, we can now control a motor with it. And in the next video, we'll take a look at how that works.